Have you ever looked up at a massive airplane soaring through the sky and wondered how something so heavy can fly? The science of flight might seem like magic, but it's grounded in physics and engineering principles. Welcome to Curiosity, everyone. In this video, we'll break down the science of how airplanes actually fly, explore the forces involved, and explain the role of each part of the aircraft. By the end, you'll understand the mechanics behind this incredible feat of human innovation. Let's get started. To understand how airplanes fly, we first need to know the four fundamental forces of flight. Lift. This is the upward force that opposes the force of gravity and keeps the plane in the air. Weight. This is the downward force caused by gravity acting on the plane's mass. Thrust. This is the forward force produced by the engines that propels the plane forward. Drag. This is the air resistance that opposes the plane's forward motion. For an airplane to take off and stay in the air, lift must overcome weight, and thrust must exceed drag. These forces work together to create stable flight. Now let's talk about lift, the most critical force that makes flight possible. Lift is generated by the airplane's wings, which are carefully designed with a shape called an airfoil. The airfoil shape is curved on top and flatter on the bottom. When the plane moves forward, air flows faster over the curved top surface and slower under the flat bottom surface. This creates a pressure difference. The faster moving air on top results in lower pressure. The slower moving air underneath creates higher pressure. This phenomenon is explained by Bernoulli's principle, which states that as the speed of a fluid, like air, increases, its pressure decreases. The higher pressure under the wing pushes the plane upward, creating lift. Next, we have thrust, the force that moves the airplane forward. Thrust is generated by the engines, which can either be jet engines or propellers. In jet engines, air is sucked in, compressed, mixed with fuel, and then ignited. The high-speed exhaust gases are expelled backward, producing a forward force, thanks to Newton's third law of motion. For every action, there is an equal and opposite reaction. This forward motion not only overcomes drag, but also allows the wings to generate lift as air flows over them. Okay, so now let's talk about drag, which is the force that resists an airplane's motion through the air. Drag actually happens because air molecules are colliding with the surface of the plane. To minimize drag, airplanes are designed with these sleek aerodynamic shapes. And modern planes use lightweight materials like carbon composites to help reduce weight and improve efficiency. The engines also need to produce enough thrust to counteract drag, especially during takeoff and when cruising at high speeds. Flying isn't just about forces, it's also about control and stability. Pilots use the plane's control surfaces to adjust its movement in 3 dimensions. Pitch is controlled by the elevator on the tail, which moves the nose up or down. Roll is controlled by ailerons on the wings, which tilt the plane side to side. Yaw is controlled by the rudder on the tail, which moves the nose left or right. Together, these controls allow pilots to maneuver the plane smoothly and maintain balance during flight. 2 other important concepts in flight are speed and the angle of attack. Speed is crucial, because for lift to occur, the plane must move fast enough for air to flow over the wings. This is why planes need a long runway to build up speed before takeoff. Angle of attack is the angle between the wing and the oncoming airflow. A higher angle increases lift, but if the angle is too high, it can stall the plane, causing a sudden loss of lift. So, careful adjustments to speed and angle of attack are critical during takeoff and landing. Once a plane is in the air, it stays there because of the balance of forces. Lift continues to counteract weight, and thrust continues to overcome drag. Modern planes are equipped with advanced autopilot systems that help maintain this balance during long flights. However, pilots are always monitoring the plane to ensure everything runs smoothly. So how do airplanes actually fly? It all comes down to the perfect combination of physics, engineering, and careful design. The four forces of flight, lift, weight, thrust, and drag, work together to keep planes in the air, while control surfaces and speed adjustments ensure stability. Next time you're on a flight, you'll know the science behind this incredible achievement. If you found this video fascinating, don't forget to like, subscribe, and hit the bell icon for more amazing science content. Thanks for watching.